So this is the experimental setup. So to the waveguide test bench. Okay, so we are connecting the either E plane T or H plane T, and we are studying its parameters. Okay. So now let us see what is E plane T and what is H plane T. So you can observe. So this is the E plane T and this is the H plane T. Okay. So how we discriminate this E plane T and H plane T means. So here you can observe the ports. So input ports. Okay. So this is the input port of E plane T and this is the input port of H plane T. Okay. So this width should be like this. Okay. So this width should be 2.3 centimeter and this should be placed in this manner only. Okay, you should not place this like this because we connect this to the waveguide. Okay, so in this manner only. Okay, so therefore so these two ports are called port 1 and port 2 and this is the port 3. So in this case, so this is port 1, port 2 and port 3. Okay, so what is the difference means? So if we give input at port 1, okay, so it will be divided into port 2 and port 3 equally, but in the opposite phase in the E plane T case. Okay, whereas in the H plane T, so this whatever the power or the input you give at the port 1, so that will be equally divided among port 2 and port 3. Okay, so that signals will be in the equal amplitude and the equal phase. Okay, so same phase and the same amplitude. But in this case, so the amplitude and the phase will be in the 180-degree phase shift or in the opposite direction. Okay, so that is the difference between E plane and H plane. So these two ports are called collinear ports and this is called side arm, or this in this case it is H arm and in this case it is E arm. Okay, so this is a side arm connected to a collinear arms. So first we shall consider the E plane T and conduct the experiment. So first connect the detector mount and generate the mode and set that output to the maximum amplitude. Okay, so and measure the voltage. So their peak to peak voltage is 2.74 volt. So take note down it as voltage V1. So replace this detector mount and connect the E plane T to this point. So now I have connected the port 1 to the input port and port 2 and port 3 are connected to the match termination. Okay, so now port 1 is input port and port 2 and port 3 are matched ports. Okay, so now so you can observe the mode. So now we need to measure the VSWR of this condition. Okay, so to measure the VSWR, so VSWR is a ratio of maximum voltage to the minimum voltage. Okay, so now you vary this tunable probe of slotted line carriage. Okay, so and measure the Vmax and the V minimum. Okay, so slowly move this knob. Okay, so the voltage is getting decreased. Okay, so up to here it is decreased. It is 68 millivolt is the V minimum. So the V minimum voltage is 68. Continue the movement of this knob so that the voltage will be increased. Okay, so then measure the Vmax. Okay, so this is the maximum voltage. It is 156 millivolt. So note down that 156 millivolt. Okay, so now we can find the VSWR from this. So VSWR is equal to Vmax divided by V minimum. Okay, so this is a Vmax and V minimum when we connected the input port to the port 1. Okay, so therefore we can say it as so Vmax 1 and V minimum 1. So now calculate the VSWR by substituting the Vmax and V minimum values. So we got VSWR is equal to 2.29 volt. Okay, so from symmetric property of E plane, okay, so we know that so S12 is equal to S21. So therefore VSWR1 of port 1 input is equal to the VSWR2 when we connect the port 2 as input. Okay, so therefore port 1 and port 2 are equal. So therefore VSWR1 is equal to VSWR2, which is equal to 2.29 volt. So in order to find the S parameters, we need to measure the voltage values. Okay, so first when we connected the detector mount, so we note down the voltage V1. So now we have connected the port 1 to the input, and port 2 and port 3 are the match termination. So now remove that match termination of port 2 and connect the detector mount here and measure the voltage V2. Okay. So I have removed the match termination which is connected to the port 2, and I have connected the detector mount, and I will measure the voltage V2. Okay, so what is the peak to peak voltage there? That is 2.42 volt is our voltage V2. Okay, so now connect the detector mount to the port 3 and measure the voltage V3. Okay, so measure the voltage, that is peak to peak voltage is 2.04, so that is voltage V3. So now I have connected the port 3 to the input, and port 1 and port 2 are matched. Okay, so now I need to measure the VSWR. Okay, so where is this SLC knob, and measure the Vmax and Vminimum. Okay, so this is our minimum voltage, it is 49.6 millivolt. Okay, so now continue to find the Vmax. Okay, so I got 144 millivolt is the maximum voltage, that is our Vmax 2. Okay, so now I have calculated the VSWR of port 3. Okay, so now I need to calculate the voltage V4 by connecting the CRO detector mount to the port 1, and port 3 is in the input. So now I have connected the detector mount to the port 1, and port 3 is in the input position. Okay, so now measure the voltage. So 2.78 voltage is the V4. So now we need to find the S parameters. So before finding the S parameters, so first find the isolation and the coupling parameters. Okay, so these isolation parameters, this is a formula 20 log V1 by V2 for I12 and I21. So substitute the values and find the I12 and I21, and similarly find I13, I31. Okay, so by substituting the voltage values, so then find the coupling coefficients by substituting the values to the formula 10 power minus I12 by 20, and for the respective coupling coefficients C12, C13, C31, etc. Okay, so after finding the coupling coefficients, so now we need to find the S parameters. So in order to find the S parameters, so first we need to find the reflection coefficients. So substitute the values of VSWR in these respective equations and find the reflection coefficients. So then find the S parameters. So the S parameters formulas are listed below. Okay, so substitute the values of reflection coefficient and the measured voltage values and find the S parameters. Okay, so now write these S parameters in the matrix form. So this is the S parameters of E plane T. Okay, so now similarly, so repeat these same steps, same procedure for by connecting the H plane T. Okay, so take the readings by connecting the H plane T and find the VSWR values, isolation and coupling coefficients, and find the reflection coefficients. Okay, so then find the S parameters of H plane T. Okay, so thus we have studied about the both E plane T and the H plane T, and we got to know how to find the S parameters of each waveguide T. Okay, what is this magic T means? So it's a combination of H plane T and the E plane T. Okay, so we can either use this as H plane T or we can use this as E plane T. Okay, so here this magic T is also called as hybrid T. It consists of 4 ports. Okay, port 1, port 2, port 3, port 4. Okay, so this is E arm and this is H arm. Okay, so we can use this either E plane T by using this arm, or we can use it as H plane by using this arm. Okay, So there is no these port 3 and port 4 are completely isolation ports. That means so there will be no power flow between port 3 and port 4 or port 4 to port 3. Okay. So first connect the detector mount and generate the mode and set the output to the maximum amplitude and measure the voltage. So here the voltage is 2.36 volt. So that is our voltage V1. So this is the experimental setup. So connect the magic T. So connect the port 1 to the input and port 2, port 3, port 4 to the match termination. So now I have connected the magic T. So the port 1 is connected to the input port and other remaining ports are connected to the match termination. Okay. So now the mode is generated. So now I need to find the VSWR in this condition. So in order to find the VSWR, I need to measure the minimum voltage and the maximum voltage. So to measure that, so rotate this SLC knob, okay, and observe the voltage. So the voltage is getting reduced. Okay. So this is the minimum voltage, 76.8 millivolt. So similarly continue this rotation in order to obtain the maximum voltage. Okay, so I got 153, 155. So that is the Vmax. So next I need to measure the voltages. V1 is already measured by connecting the detector mount. So in order to measure the V2 and V3 and V4 and V5, okay, so I need to measure these voltages. So observe this figure D, okay. So here port 1 is input port, port 3 and port 4 are connected to the match termination. So the detector is connected to the port 2, okay, and we can measure the voltage V2. So therefore, so remove the match termination which is connected to the port 2 and connect the detector mount to that port and measure the voltage V2. So observe here, so I have removed the match termination which was connected to the port 2. So in that place I have connected the detector mount. From detector mount I have connected to the CRO. So now measure the voltage V2. Okay, so here the peak to peak voltage is 222 millivolt. So that is our voltage V2. So now I need to connect the detector to the port 3 in order to measure the voltage V4. Okay, so I have connected the detector to the port 3, okay, and I need to measure the voltage V4. So voltage here is 2.36 volt. That is our V4. So in order to find the VSWR for port 3 as input, okay, so do this connection, that is give port 3 to the input port and connect the match termination to the remaining all other ports. So here you can observe, so I have connected the port 3 to the input and I have connected the match termination to all other ports. Okay, so now I have connected the CRO probe to the SLC. Okay, so now in order to find the VSWR, so rotate this slotted line carriage knob and find the Vmax and V minimum. So now voltage is getting decreased. Okay. So this is a minimum voltage. So now continue the rotation in order to obtain the Vmax. So I got 120 millivolt is the Vmax. So similarly to measure the voltage V3, so we need to connect the port 3 to the input. So now port 3 is connected to the input. So now replace the match termination of port 1 and connect the tuned detector in order to measure the voltage V3. I have connected the detector to the port 1 and measure the voltage V3. So the peak to peak voltage here is 2.38 volt, that is voltage V3. So in order to find the voltage V5, so we need to connect the detector to the port 4 when port 3 is connected to the input port. Okay, so observe here. So detector is connected to the port 4. So this is the port 4, this is port 3 is connected to the input port. Port 1 and port 2 are connected to the match termination. So now observe the voltage V5. So peak to peak voltage here is 52 millivolt. That is our voltage V5. So these are the calculations part. So I have measured the voltages and VSWR values. So I have calculated the isolation by substituting the voltage values. Similarly, I have calculated the coupling coefficients and VSWR for port 1 as input and port 3 as input, and corresponding reflection coefficients to find the S parameters. So and these are the different S parameters of Magic T.